Here in this lesson, I will analyze the question paper as well as answers of the mock test 3 subject physics held on today, the 27th May 2022. It was a question paper of 45 questions and time allotted for your answers was 45 minutes. Let us see the first question. Three bars of equal lengths and equal area of cross sections are connected in series. Their thermal conductivities are in the ratio 2:4:3. The open ends of the first and the last bars are at temperature 200 degrees centigrade and 18 degrees centigrade respectively. In the steady state, calculate the temperatures of both the junctions. In the steady state heat flow, we have three rods, and it is given that their thermal conductivities are in the ratio 2:4:3. That is, it is as 4 twice k, 4k and 3k. The open ends of the first and last bars are at temperature 200 degrees centigrade and 18 degrees centigrade respectively. In the steady state, calculate the temperatures of both the junctions. Let the first junction, that is the junction between the first rod and the second rod, having temperature θ1, and that in between the second and third rod is θ2. Now we know that the rate of heat flow Q by T equals to Ka θ1 minus θ2 divided by D. And what is given? Three bars of equal lengths. So the length of each bar is equal, and that is D. Their thermal conductivity is taken as twice k, 4k and thrice k. And what to calculate? We are to calculate the temperature of junction points of the bar 1 and 2 and 2 and 3. Now, in the steady state, Q by T is constant. Here, cross-sectional area A and length D, they are also constant. Then K into theta equals to K into θ1 minus θ2 equals to constant. That is, we find that θ1 minus θ2 is proportional to 1 by K. So the temperature difference are reciprocal to the respective thermal conductivities. So the temperature difference ratio of the first, second and third rods are in the ratio 1 by twice k is to 1 by 4k is to 1 by 3k. That is your 6 is to 3 is to 4. Then the total temperature difference in between the system is 200 degrees centigrade minus 18 degrees centigrade. So the total temperature difference is 182 degrees centigrade. That of the first rod is 182 into what? 6 over 13. 4 into 13, 52. That is, the temperature difference of the first rod is 84 degrees centigrade. That of the second rod, 182 into 3 by 13. That is your 14 into 3, that is 42 degree centigrade. Then 200 minus 84, that is your 116 degree centigrade. θ1 is 116 degree centigrade. And the temperature difference in between the two ends of the second rod is 42 degree centigrade. So θ2 is 42 degree lesser than 116, that is 74 degree centigrade. So the option A is the correct option. So the correct answer of the question number 1 is A. Now let us see the second question. The plots of intensity of radiation versus wavelength of three black bodies at temperature T1, T2 and T3 are shown. Then, now we see that the intensity of radiations are maximum at particular temperatures, that is T1 for the first curve, T3 for the second curve and T2 for the third curve. For the first curve, let it be lambda 1. For the second curve, let it be lambda 2, and for lambda 3, and for the third curve, let it be lambda 2. We know that lambda 1 is less than lambda 1 is here less than lambda 3 is less than lambda 2. Now, from Wien's displacement law, we know that lambda t equals to constant. So, t is proportional to 1 by lambda. Next, 1 by lambda 1 is greater than 1 by lambda 3 is greater than 1 by lambda 2. Now, 1 by lambda 1 is proportional to t. So, t1 is greater than t3 is greater than t2. So, our correct option is D. So, the answer of the question number 2 is D. Now, see the third question. The power radiated by a black body is P, and it radiates maximum energy at wavelength lambda 0. If the temperature of the black body is now changed so that it radiates maximum energy at wavelength 3 lambda 0 by 4, the power radiated by it becomes Np. The value of N is. Now, from Wien's displacement law, we know that lambda 0 into, let the temperature of the first body be T1 equals to, for the second one, 3 lambda 0 by 4 into T2. Then T1 by T2 equals to, T1 by T2 equals to 3 over 4. So, T2 by T1 equals to 4 over 3. Now, we know that sigma t to the power 4, E is proportional to t to the power 4, E equals to sigma t to the power 4. So, the radiation of the second case, E2, equals to sigma into T2 to the power 4, and E1 equals to sigma into T1 to the power 4. That is, the ratio is T2 by T1 to the power 4. But T2 by T1 equals to 4/3. So, this is equals to 4/3 to the power 4. 4 into 4, 16, 64, 256. 3 into 3, 9 into 3, 27 into 3, 81, 256 by 81. So, A is the correct option. So, the correct option of the question number 3 is A. Now, see the fourth question. Certain quantity of water cools from 70 degrees centigrade to 60 degrees centigrade in first 5 minutes and to 54 degrees centigrade in the next 5 minutes. The temperature of the surroundings is. So, this is a problem from Newton's law of cooling, and we are to find the surroundings temperature, and we see that the time interval is same. So, we have to apply the formula theta 1 minus theta 0 by theta 2 minus theta 0 equals to theta 2 minus theta 0 by theta 3 minus theta 0, such that initially temperature was theta 1, after time 5 minutes, let it be theta 2, and after next 5 minutes the temperature is theta 3, and theta 0 is the surroundings temperature. By the problem here, theta 1 is 70 degrees centigrade, temperature is 70 degrees centigrade minus theta 0 by theta 2 is 60 degrees centigrade by 60 minus theta 0 equals to 60 minus theta 0 by 54 minus theta 0. So, simple mathematical calculation gives us 10 by 60 minus theta 0 equals to 6 by 54 minus theta 0. This is 5, this is 3. So, we see that 180 minus 3 theta 0 equals to 270 minus 5 theta 0. Hence, 5 theta 0 minus 3 theta 0, 2 theta 0 equals to 270 minus 180, that is 90. So, theta 0 is 45 degrees centigrade. So, the surroundings temperature is 45 degrees centigrade. So, the correct option is A. Question number 4 having correct option A. Now, let us see the question number 5. A cup of tea cools from 81 degrees centigrade to 79 degrees centigrade in 1 minute. The ambient temperature, that is the room temperature, surroundings temperature is 30 degrees centigrade. what time is needed for cooling of same cup of tea in same ambience from 51 degrees centigrade to 61 degrees centigrade to 59 degrees centigrade. Now it is also a problem from Newton's law of cooling. We have to apply the cooling law here, but what is different? We have to calculate the time here. So we have to approach in such a way, in a different way, with respect to the previous problem. How to approach it? Let it be H by T, that is the rate of heat evolved, equals to K into theta 1 plus theta 2 by 2, that is the average temperature of the body, minus theta 0. So heat released per second. How is it? The temperature falls from 81 degrees centigrade to 79 degrees centigrade. H equals to MST. We know that MS into 81 minus 79, that is your 2, divided by time taken. Time taken is 1 minute. By time, it is we are putting it in minute unit, equals to K into theta 1 plus theta 2, that is your 81 plus 79 by 2, that is your 80, minus theta 0 is 30. So it is 80 minus 30. In the second case, temperature falls from 61 degrees centigrade to 59 degrees centigrade. So H is MS into T, temperature difference 61 minus 59, that is 2 by T, equals to K into average temperature of 61 and 59 is 60. So theta 1 plus theta 2 by 2 is 60 minus 30. Dividing equation 1 by equation 2, we get T by 1. T by 1 equals to, what is this? This is 50 by 30. 50 by 30 minutes. So T equals to 5 by 3 minute. 5 by 3 minute, that is your 5 by 3 into 60 second, that is your 100 second. 1 minute 40 second. So the correct answer is 1 minute 40 second. So the answer of the question number 5 is A. Now we switch over to the next question, that is the question number 6. What does it say? A sample of 0.1 gram of water at 100 degrees centigrade and normal pressure 1.013 into 10 to the 5 Newton per meter square requires 54 calorie of heat energy to convert to steam at 100 degrees centigrade. The volume of steam produced is 167.1 degrees 1 cc. The volume of steam is 167.1 cc. The change in internal energy. From first law of thermodynamics, we know that the heat is actually used in two ways. Heat given to a system. A portion is used to change the internal energy, that is du, and the rest portion is used as external work, is used to perform external work. So what to calculate? We have to calculate du. Then first see what is dq. We need 54 calorie of heat, but all the options are given in joule unit. So we have to convert calorie to joule. That is dq equals to 54 calorie equals to 54 into 4.18 joule. 8 into 54, 432, carry 43, 54 plus 43, 97, carry 9, 7, 9, 4 into 54, 216 plus 5, 9, 225. So the heat taken by the system is 225.72 calories. Now work done, that is your dW. dW equals to PdV. Now the pressure is what? A normal atmospheric pressure 1.013 into 10 to the 5 Newton per second, Newton per meter square, sorry. Let us take, for simplicity of the calculation, it is 10 to the 1 into 10 to the 5 Newton per meter square. And change in volume, its initial volume to to final volume. 1.1 gram of water having volume 0.1 cc, and the final volume when it is converted to steam is 7.1 cc. So the change in volume is 167 cc. So the change in volume is 167 cc. But we have put P in Newton per meter square unit. So we have to put dV in meter Q unit, and that is we have to multiply it by 10 to the power minus 6. So P dV is in joule unit. 10 to the 5 into 10 to the minus 6 equals 10 to the minus 1, that is 16.7 joule. So dQ is 215.72 joule. dW is 16.7 joule. So du equals to dQ minus dW, that is the difference in between the two, will give us 208 point some joule, that is your 0.720 209 joule approximately. So the nearest option is 208.7 joule. So B is the correct option of the question number 6. Now let us see the question number 7. It is a simple question from thermodynamics. What does it say? An ideal gas having molar specific heat capacity at constant volume is 3 by 2R. That is your Cv equals to 3 by 2R. The molar specific heat capacity at constant pressure is, all you know, Cp minus Cv equals to R. Then Cp equals to Cv plus R. When Cv is 3 by 2R, then Cp is obviously 5 by 2R. It was the easiest question of the lot. So the correct answer is 5 by 2R. So the answer to the question number 7 is B. Now let us see the question number 8. In question number 8, we see that for the given isothermal process, it is the isothermal process A to B of an ideal gas. Area under the graph is 20 joule. Then area under the graph is 20 joule. Then what is the value of del Q? Now, in an isothermal process, as temperature remains constant, and all you know that temperature actually governs the internal energy of the gas. As the temperature remains constant, there is no change in internal energy of the system. But area under the curve gives the work done, dW equals to 20 joule. So from first law of thermodynamics, we write down dQ equals to du plus dW. So dQ or del Q equals to du is 0, dW is 20 joule, so dQ is 20 joule. So our answer is plus 20 joule. So answer to the question number 8 is B. 8B is the correct choice here. Now let us see the question number 9. It is also from thermodynamics. In one adiabatic process, the pressure is increased by 2 by 3%. If Cp by Cv equals to 3 by 2, then the volume decreases by amount what? In an adiabatic process. And pressure is increased and change in volume. We know that the relation in between pressure and volume for an adiabatic process is Pv to the power gamma equals to constant, let it be C. Now taking log ln P plus gamma ln V equals to ln C. Now differentiating we get 1 by P dP plus gamma by V dV equals to 0. What we need? We need to calculate the volume, fractional change in volume, but the fractional change in pressure is given. So dV by V, gamma into dV by V equals to minus dP by P. So dV by V equals to 1 by gamma into dP by P if we get the only numerical value, because the sign is not given there. Here dP by P is what? 2 by 3%. So dP by P is 2 by 3. And gamma is 3 by 2, Cp by Cv, that is your gamma is 3 by 2. So 1 by gamma is also 2 by 3. So dV by V equals to what? 2 by 3 into 2 by 3, that is 4 by 9%. We find this 4 by 9% in the option A. So our choice is A for the question number 9. Now let us see the question number 10. In an isobaric process, the work done by a diatomic gas is 10 joule. The heat given to the gas will be Cv for diatomic gas is given 7 by 2R. We know that Cv is lesser from Cp by an amount R. So Cv equals to 7 by 2R minus R equals to 5 by 2R. Now, in an isobaric process, when the pressure is constant, work done by the gas, we know that work done by the gas equals to N into Cp minus Cv into dt. Because NCP dt total heat given are and NCV dt is the change in internal energy. So that is dq minus du equals to dw. That is your dw. And dw is 10 joule. So this is equals to 10. N into Cp minus Cv, that is your R, into dt equals to 10. So N dt equals to what? 10 by R. Heat given to the gas will be. So we need to calculate. We need to calculate the heat given to the gas. Now we know that this is dW. Now we have to calculate du. What is du? Du equals to NCV dt. N dt equals to 10 by R, and Cv, as we have already calculated, is 5 by 2R. 5 by 2R. R cancel out, it is 25 joule du. And dW is 10 joules. So dq equals to du plus dw. Adding 25 with 10, we get 35 joule. So the heat given to the gas should be 35 joule. We find 35 joule in option A. So our correct option to the question number 10 is A. Let us see the next question, that is your question number 11. In question number 11, the efficiency of an ideal gas with adiabatic component gamma for the shown cyclic process. Here is a cyclic process BACB. It is a cyclic process here. And we have to calculate the efficiency. Efficiency what? Efficiency means delta W by Q. Heat given is Q and delta W equals to total work done. Now let us see the processes. In the process CB, here we get a straight line and which will pass through the origin. So the pressure is constant. So we get that the work done in this process is WCB equals to what? PdV equals to what? NR into dt equals to NR into dt. What is dt? dt is the difference in temperature. Final temperature is T0 and initial temperature is twice T0. So dt is T0 minus twice T0. That is your minus NR into T0. What is this? This is WCB. Now, in the process WBA, here volume is V0, volume constant, so it is a isochoric process. In isochoric process, work done is 0. So WBA equals to 0. And in the process WAC, we see that in this process temperature remains constant, so it is an isothermal process. In this process, work done is nRT ln V2 by V1. nRT ln V2 by V1. That is your nR into T. What is T? T is twice T0 into ln V2 by V1. V2 is final volume, that is your 2V0, and initial volume was V0, so that is ln 2. 2V0 by V0 equals to ln 2. So it is 2 nR T0 ln 2. 2 nR T0 into ln 2. So the total work done, that is your WCB plus WBA plus WAC, equals to what? Delta W equals to nR T0 is common here into 2 ln 2 from the first term. From the first term, 2 ln 2, nR T0 into 2 ln 2 minus 1. And now we have to calculate delta Q. What is the value of delta Q? Delta Q equals to what? Delta Q BC. That is in the process B to C delta Q. What is that? Delta Q equals to input heat equals to NCP into dt. NCP into dt. What is that? N, what is CP? CP is gamma R by gamma minus 1 into dt. What is dt? In the process B to C, T0 to twice T0. So the change in temperature is final temperature twice T0 minus initial temperature T0. So that is your my nR into T0 into gamma by gamma minus 1. So the efficiency eta equals to delta W by delta Q equals to what? nR T0 will cancel out nR T0 into what? 2 ln 2 minus 1 divided by nR T0 into gamma by gamma minus 1. nR T0 will cancel out from numerator and denominator. So the answer is 2 ln 2 minus 1 by gamma minus 1. That is option number A is the correct option. So the answer to the question number 11 is A. Now let us see the question number 12. What does it say? Let us see the question number 12. Figure below shows two paths may be taken by a gas to go from a state A to state C. State A and state C, two paths may be taken. Number 1, A to C, and number 2, A to B via A to C via B, AB to BC. That is, in process AB, 400 joule of heat is added to the system. In this process, 400 joule heat is added to the system. And in process BC, 100 joule of heat is added to the system. The heat absorbed by the system in the process AC will be. Now we have to calculate the heat added to the system in the process AC. Now let us see for the first process. What is the first process? In the process A to B, what is that? Volume remains constant. So in the process AB, 400 joule heat is added to the system in the process BC. In the process BC, in this process, pressure remains the same, but there is a change in volume. So the work done. What is the value of work done here? Delta W. Delta W equals to what? Delta W, work done, equals to the area of the triangle. Area of the triangle, and the base of which is P, and P remains the same, and the volume changes. So there is the area of the triangle equals to half into base into height. That is your delta P equals to 4 into 10 to the power 4. In between A and B, that is 4 into 10 to the power 4 Pascal. And what is the change in volume? 2 into 10 to the power minus 3 meter cube. So here PV delta W equals to half into change in volume 2 into 10 to the power minus 3 meter cube and change in pressure 4 into 10 to the power 4 Pascal. So that is equals to your 40 joule. So delta Q, there is no change in internal energy. So delta Q equals to 40 joule. Gas from state A to state C. In the process AB, 400 joule heat is added to the system, and in the process BC, 100 joule heat is added to the system. The heat absorbed by the system in the process AC will be heat absorbed by the system. As initial state is A, final state is C, so the change in internal energy in both the process is same. So we are to calculate only the heat taken by the system. Now, in the whole cyclic process, how the heat taken? In the process B to C, heat taken is 40 joule. Now, total heat taken by the system, what is that? That is your QAB plus what? Plus QBC plus what? Plus QCA plus QCA. And what we find that is equals to the area under the curve is 40 joule, because change in internal energy in both the process is same. So QAB equals to 400 joule given, QBC given as 100 joule. What we need? We need heat absorbed in the process AC. So QAC or QCA equals to 40. So QCA equals to what? 40 minus 500, that is your minus 460 joule. So the correct answer is minus 460 joule. So the correct answer in the process AC, we have calculated CA. So in the process AC, QAC equals to 460 joule. So our correct answer is D of the question number 12. Now let us see the question number 13. What does it say? Let us see that. If 10 to the power 22 molecules, each of mass 10 to the minus 26 kg, collide with a surface elastically per second over an area 1 meter square with a speed 10 to the power 4 meter per second, the pressure exerted by the gas molecules will be of the order of the pressure exerted by the molecule. Here, the change in momentum. Molecules are impinging on the wall with momentum mu, and they are going away with also momentum mu. Initial momentum was minus mu, final momentum is mu. So the total change in momentum is 2 mu. Mu minus of minus mu equals to 2 mu. Now, so delta P, change in momentum, 2 mu, 2 into, what is m? The value of m is 10 to the power minus 26 into, what is u? U is 10 to the power 4. And how many molecules are there? 10 to the power 22. So the total change in momentum into 10 to the power 22, that is your 2 Newton per meter square. So, or kg, that is your 2 kg meter per second. Change in momentum. So the force exerted, force into area. Area is 1 meter square. So the force equals to delta P. Delta P is the change in momentum. So force equals to delta P by T. Delta P by T. What is the time taken? Per second. So the force is 2 Newton. Now pressure. Pressure equals to what? Force per unit area. F by A. What is that? 2 Newton by 1 meter square. That is your 2 Pascal. 2 Pascal. So that is your 2 into 10 to the power 0. So the order is 10 to the power 0 Newton per meter square. C is the correct answer. So the answer of the question number 13 is C. Now see the question number 14. In the question number 14, the molecules of a given mass of a gas have RMS velocity of 200 meter per second at 27 degrees centigrade and 1 into 10 to the 5 Newton per meter square pressure. When the temperature and pressure of the gas are respectively 127 degrees centigrade and 0.05 into 10 to the 5 Newton per meter square, the RMS velocity. We know that RMS velocity C equals to root over 3 RT by M. Here the expression is pressure independent. So C is proportional to root over of T. Now, initially RMS velocity is 200 meter per second. Now C1 by C2 equals to root over T1 by root over T2. C1 is 200 meter per second. We have to calculate RMS velocity. In the second case, that is your C2 equals to what is T1, 27 degrees centigrade, that is your 300 Kelvin. And what is T2? It is 127 degrees centigrade, that is your 400 Kelvin. Let us put it there, 400. So C2 equals to 200 into 2 by root 3, that is 400 by root 3. So the correct option is A. Correct option of the question number 14 is A. Now let us see the question number 15. In question number 15, we see that a gas mixture consists of 2 mole of oxygen and 4 mole of argon at temperature T, neglecting all vibrational modes. The total internal energy of the system is here 2 mole of oxygen. Tale 2 mole of oxygen, there are twice n number of molecules and each molecule having 5 degrees of freedom. Total energy is 5 by 2 into kT. Plus for argon there are 4 mole. Total number of molecules is 4n into argon having 3 degrees of freedom. Energy is 3 by 2 kT. Now K equals to R by N. So N into 5 into R by N into T plus 4N into 3 by 2 into K means R by N into T. That is your 5 RT plus 6 RT equals to 11 RT. So D is the correct answer. So the answer of the question number 15 is D. Now let us see the question number 16. In the question number 16, the value of gamma for hydrogen, helium and another ideal diatomic gas whose molecules are not rigid but having an additional vibrational mode are respectively. Gamma for hydrogen. Hydrogen is diatomic gas and its gamma is 7 by 5. Helium, it is a monatomic gas and its gamma is 5 by 3. Now we have to calculate gamma for another diatomic gas whose molecules are not rigid but have additional vibrational mode. And for this additional vibrational mode, its internal energy is U equals to 7 by 2 into K into T into N. That is your del U del T equals to 7 by 2 K equals to R by N into T into N cancel out. So del U del T V equals to what? 7 by 2 into R. 7 by 2 into R. This is Cv. Then Cp equals to 9 by 2R. So Cp by Cv, that is your gamma, is 9 by 2R by 7 by 2R, that is 9 by 7. So 3 values are there 7 by 5, 5 by 3 and 9 by 7 respectively for hydrogen, helium and another diatomic gas found in question option number A. So our correct choice of question number 16 is option A. Now let us see the question number 17. In question number 17, the specific heats Cp and Cv of a gas of diatomic molecules A are given in units joule per mole per Kelvin by 29 and 22 respectively. Cp and Cv for A is 29 and 22, and for another gas of diatomic molecules B has corresponding values 30 and 21. If they are treated as ideal gas, then what is correct? Now see, have there any vibrational mode or not? That is actually the option says A has vibrational mode, B has none. A and B has vibrational mode. A has one vibrational mode in C and B has two. A is rigid, B has a vibrational mode. Whether vibrational mode is present or not, we have to treat it through gamma. For A, gamma equals to Cp by Cv. And from question, Cp is 29 for A and Cv is 22. So the ratio is 29 by 22. That is your 1.3. And for B, it is 30 and 21 respectively. So for B, gamma B equals to 30 by 21. That is your 10 by 7, nearly 1.4, equals to 1 plus 2 by A. So 2 by A equals to what? 0.4. A equals to 5. 5 degrees of freedom for a diatomic gas. Here, both the gases are diatomic. When there are 5 degrees of freedom, there is no vibrational mode. So for B, there is no vibrational mode. And what about A? It is 1.3 nearly equals to 1 plus 2 by A. So 2 by A is 0.3. So A equals to 20 by 3, nearly 6.67, that is 7. So vibrational modes are added there. So A has vibrational mode but B has none. So correct answer of the question number 17 is A. Let us see the question number 18. Question number 18. Consider an ideal gas confined in an isolated closed chamber. As the gas undergoes an adiabatic expansion, the average time of collision between molecules increases as V to the power Q, where V is the volume of the gas. The value of Q is, we know that average time of collision tau equals to 1 by n pi into V, average V into d square, where n is the number of molecules per unit volume. Now, so tau is proportional to 1 by n into V. And now n is proportional to 1 by V, and V RMS, this is V or this is V RMS. V RMS is proportional to what? Root T. So tau is proportional to V by root T. T is the temperature of the gas molecules. Now, expansion is adiabatic one. And for adiabatic expansion, we know that T into V to the power gamma minus 1 is one constant. So root T equals to C1 into V to the power 1 minus gamma by 2. 1 minus gamma by 2. So tau equals to what? V by root T. Now here root T, how it happens? T equals to C by V to the power gamma minus 1. So root T, when we taking the root of the left hand side, we have to take roots of the right hand side also, and where root C equals to C1 and V, when it is taken from denumerator to numerator, it will change to v to the power 1 minus gamma by 2. So tau equals to v by root t. That is v by root t means proportional to, we may put proportional sign. So C1 may be avoided there by v to the power 1 minus gamma by 2. So tau is proportional to v to the power gamma plus 1 by 2. We see that in the question it is v to the power q. So comparing it, we get q as v to the power q, so q as gamma plus 1 by 2, it is found in option C. So the answer of the question number 18 is C. Let us see the question number 19. It is a question from simple harmonic motion. The simple harmonic motion figure depicts a circular motion. The radius of the circle of revolution, initial position and sense of revolution are indicated on the figure. Sense of revolution is anti-clockwise, time is 4 seconds and angle is 45 degree. The simple harmonic motion of the x projection of the radius vector rotating particle p is. Now we have to give the equation of the simple harmonic motion. Here amplitude is a, and what is that? If we find the x projection, then it will be x by a equals to cos. And now the particle rotates in time t, the angle is omega t. So whole angle is omega t plus 45 degree means pi by 4. So the whole angle is omega t plus pi by 4. So we find that x by a equals to cos omega t plus pi by 4. Omega means 2 pi by capital T. Capital T is the time period is 4. So omega equals to 2 pi by 4 radian per second. So x equals to what? X equals to a cos pi by 2 or 2 pi by 4 into t plus pi by 4. So A is the correct option. So the question number 19, we get the answer as the option A. Now we see the question number 20. In question number 20, it is also a question from simple harmonic motion. The xt graph of a particle undergoing simple harmonic motion is shown below. Here is a xt graph. Xt graph, t along x-axis and x along y-axis. The acceleration of the particle is, we are to calculate the acceleration. Now, it is 1 unit, so the amplitude is 1 unit. Now, the equation of S.H.M, x equals to a sine omega t. We see that the curve is sinusoidal curve. And omega equals to 2 pi by t, and here complete cycle, complete vibration completes at t seconds. So the time period of vibration is 8 seconds. So this is omega equals to 2 pi by 8 or pi by 4. Omega equals to 2 pi by 8 or pi by 4. So what we see, a equals to 1. A equals to 1. So x equals to a sine omega t and omega equals to 2 pi by 8 equals to pi by 4. Now what to calculate? Acceleration of the particle. Acceleration, a equals to, we know that minus omega square x, and x equals to a sine omega t. So x equals to a1 sine omega t at time, at which time t equals to 4/3 second. Omega is pi by 4. So this is sine pi by 4 into t is 4/3 into 4/3. That is your sine pi by 3. Sine 60 means root 3 by 2. So a equals to minus omega square. Omega equals to pi by 4 whole square into root 3 by 2. That is your minus pi square into 3 by 32. Root 3 pi square by 32, that is option number D is our correct option. Root 3 pi square by 32 with negative sign. So the correct answer of the question number 20 is D. Now see the question number 21. We see that in question number 21, it is also a question from S.H.M. A particle executes linear simple harmonic motion with an amplitude of 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity equal to that of its acceleration. Then its time period in second is. Actually, the expression for velocity is omega into root over of a square minus x square. And when it is at 2 centimeter from the mean position, the magnitude of velocity equals to that of acceleration, and the value of acceleration is omega square into x, magnitude of acceleration. Omega being cancel out. What do we see? A is 3 centimeter, 3 square minus x is 2 square equals to omega into 2. So 2 omega equals to 9 minus 4 root 5. So omega equals to root 5 by 2. We need the time period. T equals to 2 pi by omega equals to 2 pi by omega root 5 by 2, that is your 4 pi by root 5. So C is the correct answer. So the answer to the question number 21 is C. Now, the time period of the system shown below. There are 3 springs having force constant K, K and twice K respectively. First 2 springs are in parallel combination, so the coupled vibration will give you the force constant of the equivalent spring is twice K. Now, both the springs will vibrate. Now, the equivalent spring of K and K force constant is twice K. So, you may replace this spring by one spring of force constant twice K. When 2 springs are there, they are also twice K and twice K force constant springs are in parallel combination. So, they will give us the equivalent force constant as 4K. Now, the time period, we know that T equals to 2 pi root m by force constant, and now the equivalent force constant is 4K. So, T equals to 2 pi root m by 4K. So, the correct option of the question number 22 is C. Now, switch over to the next question, that is the question number 23. A simple pendulum oscillating in air has time period T, that is T equals to 2 pi root L by G. The bob of the pendulum is completely immersed in a non-viscous liquid. The density of the liquid is 1/16 of the material of the bob. If the bob is inside the liquid, all the time its period of oscillation. Now, period of oscillation Bt dash equals to twice pi root L by G dash. When the bob is immersed in a liquid, we have to calculate the equivalent G dash in this case. Let the volume of the bob be V. Then the weight of the bob V into rho into G minus buoyant force acting. The density of the liquid is 1/16 that of the material of the bob. So the buoyant force equals to V into rho by 16 into G equals to what? V into rho into G dash, that is the equivalent G. So V rho being cancelled out from both sides. So G dash equals to G into 1 minus 1 by 16, that is your 15G by 16. Hence T dash equals to 2 pi root L into 16 by 15G. That is your 2 pi root L by G into 4 by root 15. 4 by root 15. That is your 40 by root 15. 40 by root 15. That is D is the correct option to the question number 23. So, our choice for the question number 23 is D. Now, let us see the next question, that is our question number 24. It is a question from efficiency of a heat engine, that is from second law of thermodynamics. The efficiency of a heat engine is 1/6. We know that. efficiency eta equals to 1/6 equals to 1 minus T2 by T1, where T2 is the sink temperature by source temperature. When the temperature of the sink is decreased by 62 degrees centigrade, the efficiency is doubled. Now efficiency is doubled, that is 1/6 into 2, that is 1/3. When sink temperature is decreased by 62 degrees centigrade, or it is decreased by 62 Kelvin. So when T2 is T2 minus 62 by T1, then efficiency is 1/3. Efficiency is 1/3. So T2 minus 62 by T1 equals to what? 1 minus 1/3 means 2/3. And T2 by T1 was that equals to 1 minus 1/6 from the first relation is 5 by 6. So T2 by T1, that is your 5 by 6 minus 62 by T1 equals to 2/3. So 62 by T1 equals to 5 by 6 minus 2/3, that is 6. 5 minus 4, 1. So T2 equals to 6 into 62, that is 372 Kelvin. So, T1 equals to 372 Kelvin. So, what is the temperature of the source? 372 Kelvin. So, B is the correct answer. Correct answer of the question number 24 is B. Now, see the question number 25. An ideal refrigerator has freezer at a temperature minus 13 degrees centigrade. The coefficient of performance of the engine is 5. The temperature of air will be, we know that, coefficient of performance alpha equals to Q2 by Q1 minus Q2 equals to T2 by T1 minus T2. And it is given as 5 equals to, what is T2? T2 is minus 13 degrees centigrade. That is your plus 273 equals to 260 Kelvin. So T2 is 260 Kelvin by T1 minus 260 equals to 5. So T1 minus 260 equals to 260 by 5, that is your 52. So T2 is 52 plus 260, 312 Kelvin. 312 Kelvin, but there is no 312 Kelvin. Other answers are in degree centigrade, so you have to convert it in degree centigrade. Just minus 273, that is 39 degrees centigrade. So our correct option is C. So correct answer to the question number 25 is C. Let us see the question number 26. In this question, the displacement time graph of a particle executing S.H.M is shown in figure. Which of the following information are inaccurate? কোন ইনফরমেশনটা আমাদের inaccurate এটা খুঁজে বের করতে হবে। The force is 0 at t equals to 3t by 4. We know that force equals to m omega square x. When x is 0, then force is 0. But we know that at 3t by 4, displacement is 0, so the force is 0. It is a correct option, but we have to find the inaccurate answer. The acceleration is maximum. Acceleration is maximum at x equals to a, at t equals to t. When we find that t equals to t, x equals to a, so the acceleration is maximum there. The velocity is maximum at t equals to t by 4. We know that velocity is maximum at x equals to 0 and it is at the mean position. So t equals to t by 4, displacement is 0, the particle is at the mean position. So all these three options are correct. Then there must be inaccurate option, should be D. So our inaccurate option of question number 26 is D. And it says that the kinetic energy equals to potential energy. It happens when x equals to plus minus a by root 2. And it happens at t equals to t by 8, not t by 4. So this is the wrong option and we have to Find the inaccurate answer. So D is the inaccurate answer. So our choice for the question number 26 is D. Now let us see the question number 27. Question number 27. Match column 1 with column 2 and select the correct answer for codes given below. First, thermal resistance. Second, Stefan's constant. Third, Wien's constant. Fourth, heat current. Wien's constant is lambda m into T. So its dimension is Lk. So Wien's constant is 4. So C is found in 4. C having correct answer 4. C having correct answer 4. We find it only in option C, first of all. Now, Stefan's constant. Stefan's constant means E equals to sigma into T to the power 4. So, sigma equals to E by T to the power 4. But E means energy per unit area per second into theta to the power 4. That is your m, there is no L, m T to the power minus 3 theta to the power minus 4. m T to the power minus 3 theta to the power minus 4. So Stefan constant that is B is found in 1. B is in 1, C is in 4, and other options and calculating thermal resistance and heat current from the equations we must come to the conclusion that C is our correct option. So the question number 20C having the correct option C. Now let us see the question number 28. It is a question from thermodynamics. A cyclic process for 1 mole of an ideal gas is shown in the VT diagram. The work done AB, BC and CA respectively. In the process AB, it is a isochoric process. So in this process, WAB, work done is 0. Work done is 0. Now, next in the process BC, WBC. BC is an isothermal process, so the work done is R, temperature is T2, ln V2 by V1. And in the third process, CA, it is a straight line passing through the origin, so pressure is constant, so the work done WCA equals to P into dV. PV equals to R dt, তাহলে R into what? Final temperature minus initial temperature. Here for the process CA, final temperature is T1 and initial temperature is T2. So the answer is R into T1 minus T2. So the correct option WAB 0, WBC RT2 ln V2 by V1 and WCA R into T1 minus T2. We find all these options in option number D. So 28D is our correct choice. Now let us see the question number 29. It is a question from thermodynamics. Question number 29 is also a question from thermodynamics. A cyclic process is shown in the figure. The work done during the cyclic process A, B, C, D, A equals to area under the cycle, and it is a trapezium. We find that the area equals to half into sum total of the length of the parallel arm, that is your AB. It is AB, it is clear that V is at A 1 meter cube and at B 3 meter cube, so AB length is 2 meter cube plus another arm 1 to 2, that is DC, that is 1 meter cube into perpendicular distance in between them, that is your AD. At A, pressure is 2 into 10 to the power 2 and at D, the pressure is 10 to the power 2. So the length AD indicates pressure 2 into 10 to the power 2 minus 10 to the power 2, that is your 100 Newton per meter square by 100 or 100 Pascal into 100. So what is that? 150 joule. 3, 250, 50 into 3, 150 joules. So correct option is B. The correct option of the question number 29 is B. Now let us see the question number 30. A gas expands with temperature according to relation. According to relation, V equals to K 2 to the power 2/3. T to the power 2/3, where K is a constant, the work done by the gas. When the temperature changes by 60 Kelvin, we have to calculate the work done by the gas when the temperature changes by 60 Kelvin. We know that. Work done W equals to integration P dV. And as it is not given, we take 1 mole gas, then P equals to RT by V into dV. But V is given in terms of T, so we have to replace V in terms of T as V equals to K into 2 to the power T to the power 2/3. So dV equals to K into 2/3 into T to the power minus 1/3 into dt. So dV by V equals to K into 2/3 into T to the power minus 1/3 dt whole divided by V means K into T to the power 2/3. K cancel out, 2/3 into T to the power minus 1 into dt. So putting all these values here in the integration, we get R T into 2/3 into T to the power minus 1 into dt. That is your 2/3 R into integration only dt. That is your T. That is your T. That is the change in temperature. That is 60 Kelvin. So put 60 in place of T. Putting 60 in place of T, we get that the answer is 40 R. So the work done is 40 R. So our correct choice is C. So the correct choice to the question number 30. Sorry, question number 30 is C. Now see the question number 31. In 31, the kinetic energy of a particle increased to 16 times its previous value. The percentage change in de Broglie wavelength. So de Broglie wavelength lambda equals to h by mv, and if we express it in terms of kinetic energy, that is h by root over 2ma. If energy is 16 times, then lambda dash equals to lambda by 4. Root over of 16 is 4. So the de Broglie wavelength is 25%. But what is the question? Percentage change in de Broglie wavelength. It is only 25% now, so the change is 75%. So the correct option is B. So correct option to the question number 31 is B. Now let us see the question number 32. In 32, a source S1 is producing 10 to the power 15 photons per second of wavelength 5000 angstrom. Another source S2 producing 1.02 into 10 to the power 15 photons per second of wavelength 5100 angstrom. Then the power S2 by S1. Power S2, PS2 by PS1. PS2 what? N2 into HC by lambda 2. Power S1 what? N1 into HC by lambda 1. That is your N2 by N1 into lambda 1 by lambda 2. So N2, what is N2? 1.02 into 10 to the power 15 number of photons. So it is 1.02 into 10 to the power 15. What is N1? N1 is 10 to the power 15. N1 is 10 to the power 15 into lambda 1. Lambda 1 was 5000 angstrom. And lambda 2 is 5100 angstrom. 0 being cancelled out, 10 to the 15 being cancelled out, 1.02 into 50 by 51. That is your 51 by 51, that is 1. The ratio is 1. So correct option to the question number 32 is A. Now let us see the question number 33. In this question, the Broglie wavelength of a particle moving with a velocity 2.25 into 10 to the power 8 meter per second is equals to the wavelength of a photon. The ratio of kinetic energy of the particle to the energy of photon. Kinetic energy of a particle is half mv square. And energy of the photon, the ratio and energy of the photon is hc by lambda, but both having wavelength equal. So for the particle, lambda equals to h by mv. So mv equals to h by lambda. So you may put v by 2 into mv, that is h by lambda, divided by hc by lambda. So the required ratio equals to h and lambda being cancelled out, we find it v by 2c. But v is what? 2.25 into 10 to the power 8. 2.25 into 10 to the power 8. What is c? c is 3 into 10 to the power 8. So 10 to the power 8 being cancelled out. 2.25, that is your 2.25, that is your 225 by 100 into 6. 4 into 25, 9. 3, 2, so the ratio is 3 by 8. That is B. So the question number 33 has the correct option B. Now let us see the question number 34. What does it say? In question number 34, we see a graph. Figure represents a graph of kinetic energy of most energetic photons K max in EV, and it is found from the graph, it is 3 electron volt. And frequency nu of a metal used as cathode in photoelectric experiment. The threshold frequency of light for the photoelectric emission for the metal is. Here, from the graph it is clear, when nu is 10 to the power 15 Hertz, maximum kinetic energy is 3 electron volt. We have to start from here. We have to start just from here. What is that? Emax. What is Emax? Emax equals to h nu minus h nu 0. Emax equals to h nu minus h nu 0. The threshold frequency, we need to calculate the threshold frequency of light. So we have to find nu 0. And Emax should be replaced in terms of h. E is 3 electron volt. E is 3 electron volt. E is 3 electron volt actually. So 1 electron volt is 3 electron volt, and what is given that it is 10 to the power 15 Hertz, and we have to calculate nu 0. Emax is 3 electron volt. Emax is 3 electron volt. Emax is 3 electron volt. We have to express it in terms of nu. So, in terms of nu, E equals to H into nu. E is 3 electron volt, then 3 into 1.6 into 10 to the power minus 19 joule equals to 6.6 into 10 to the power minus 34, or we may write H there into nu. So nu is E equals to H nu, 3 electron volt, then that is your H nu. H nu, E is 3 electron volt, that is your 4.8 into 10 to the power minus 19. 4.8 into 10 to the power minus 19 joule. And this is H nu minus H nu 0. 4.8 into 10 to the power minus 19 joule. And this is equals to H into nu. So this is equals to H nu. Emax may be calculated in this way. H nu, H into 10 to the power 15 minus H nu 0, and it may be calculated as H into 0.728 into 10 to the power 15. So H may be cancelled out from both sides. So nu 0 equals to 2.7 into 10 to the power 14. 2.7 into 10 to the power 14. So correct answer is 2.7 into 10 to the power 14. So correct answer to the question number 34 is D. Now see the question number 35. In question number 35, an electron in an excited state of hydrogen, it has a total energy minus 3.4 electron volt. The kinetic energy of the electron is E, the Broglie wavelength is lambda. When total energy of the orbit equals to the kinetic energy, numerically they are equal. So the numerical value of kinetic energy is 3.4 electron volt. Now we have to calculate the Broglie wavelength. Lambda equals to h by root over 2me. And from short tricks we know that it is as 12.27 divided by energy is 3.4 electron volt, so the corresponding voltage is 3.4 volt. We will find it in angstrom unit, and simple calculation gives us the value as 12.27 by root over of 3.4 means nearly 1.85, which gives us 6.7 into 10 to the power minus 10 meter. The answer was given in angstrom unit, the earlier line, and if we put 1 angstrom equals to 10 to the power minus 10 meter, we get 6.7 or 6.67 into 10 to the power minus 10 meter. So B is our correct choice to the question number 35. 35B is our correct choice. Now let us see the question number 36. An electron is moving in an orbit of hydrogen atom, which there can be a maximum 6 transitions. 6 transitions means 4C2 equals to 6, so it is in the fourth state. An electron is moving in an orbit of another hydrogen atom from which there can be maximum 3 transitions, and it is possible from 3C2, that is equals to 3, so it is in the third orbit. The ratio of velocities of electron in these two orbits, we know that velocity V equals to C by 137 into Z by N. So their velocity ratio is C by 137 for the first one into 1 by 4 divided by C by 137 into 1 by 3. So the ratio is 3 by 4. So D is the correct option to the question number 36. So the correct option to the question number 36 is D. Now let us see the question number 37. A fraction of atom of radioactive element that decays in 6 days is 7/8. The decayed portion is 7/8. So undecayed portion is 1/8. That is half to the power 3. So there are 3 half-lives, 3 into T half. That is the time 6 days. So T half is 2 days only. The fraction that decayed in 10 days, if there are 10 days, we have 5 half-life, 5 into T half. So the non-disintegrated fraction is half to the power 5, that is 1 by 32. But the fraction that decays, so the decayed fraction is 1 minus 1 by 32, that is 31 by 32. That is our correct choice. So C is the correct answer. Answer to the question number 37 is C. Now let us see the question number 38. A reactor is developing energy at a rate of 3000 kilowatt. How many atoms of uranium-235 undergo fission per second if 200 MeV energy is released per fission? So 300 kilowatt energy is needed. 3000 kilowatt means 3000 into 100 watt. How many U-235 atoms undergo fission per second if 200 MEV energy is released for fission. We need n number of fissions, and from each fission there are 200 MEV energy, that is 200 into 1.6 into 10 to the power minus 13 joule. So you have to calculate just n. N equals to 3 into 10 to the power 5 by 3.2 into 10 to the power minus 11. So 3 by 3.2. 3 by 3.2, that is your 30 by 32. 30 by 32 into 10 to the power 16, 17, 16. Let it be 10 to the 5. This is 10 to the power minus 11. So 3 by 32. 3 by 32. 3, 6. This is 3 into 3 kilowatt. 1 kilowatt means 1000 watt. Then here is another 10. So this is 10 to the power 17. This is equals to 9.4 into 10 to the power 16. So our correct answer is 9.4 into 10 to the power 16. So correct choice of the question number 38 is D. Now see the question number 39. In an electron in hydrogen atom, if an electron in hydrogen atom jumps from third orbit to second orbit, it emits a photon of wavelength lambda. So he says that 1 by lambda equals to R into third orbit to second orbit, 1 by 2 square minus 1 by 3 square. When it jumps from fourth orbit to third orbit, the corresponding wavelength is lambda 1, then 1 by lambda 1 equals to R into fourth to third equals to 1 by 3 square minus 1 by 4 square. From the first equation, it is R into 9 minus 4 means 5 by 36. For the second equation, it is R into 4 square, 16 minus 9 means 7 by 144. So lambda 1 by lambda, dividing equation 1 by equation 2, lambda 1 by lambda equals to 5R by 36 into 144 by 7R. 36 into 4, 144. R being cancelled out, that is 20 by 7. 20 by 7. So lambda 1 equals to 20 lambda by 7. C is the correct choice. So the correct answer of the question number 39 is C. Now let us see the question number 40. In question number 40, what is the conductivity of a semiconductor if electron density is 5 into 10 to the power 12 per centimeter cube, hole density is 8 into 10 to the power 13 per centimeter cube, mu E and mu H are given, mobility are given, then you have to calculate it. That is sigma equals to N into E into mu E plus P into E into mu H. So N, what is the value of N? N is 5 into 10 to the power 12 per centimeter cube. 1 centimeter cube equals to 10 to the minus 6 meter cube. So we will get another 10 to the power 6 there. So into 10 to the power 6 electronic charge. Ultimately, we will put it there, 1.6 into 10 to the power minus 19 coulomb into mu E into 2.3 plus P, hole density, 8 into 10 to the power 13. Similarly, it is also in centimeter per centimeter cube. In per meter cube, it is 10 to the power 6 into mu H is 0.01. So, here we have a simple calculation which gives us 10 to the power 18, 11.5 plus 10 to the power 18 means 80, 80.01.8 into 10 to the power, actually 18 into 1.6 into 10 to the power minus 1. That is your 12.3 into 1.6 into 10 to the power minus 1 equals to 3 into 16, 48, 8 carry 4, 2 into 16, 32 plus 4, 36, carry 3, 16 plus 3, 19, 1, 2 and 10 to the minus 3, 1, 1.968. So B is the correct choice to the question number 40. Now we see the question number 41. It is a diode related problem. We see that the circuit shown in the figure contains 3 diodes with forward resistance 50 ohm and with infinite backward resistance. The battery voltage is 6 volt, the current through 100 ohm resistor. We see that first 2 diodes D1 and D2 is in forward bias and D3 is in reverse bias. So we may we may neglect the existence of this arm from the equivalent circuit. Now forward bias resistance is 50 ohm, so the equivalent resistance of the upper arm is 200 ohm and that of the second arm is also 100 ohm. And this 100 ohm and 200 ohm are in parallel combination, so their equivalent resistance is 200 into 100 by 300 ohm, that is 200 by 3 ohm. And there is also 100 ohm resistance in series, hence the equivalent resistance of the circuit is 200 by 3 plus 100, that is your 500 by 3 ohm. Now there is a EMF of the battery is 6 volts, so the current is 6 by 500 by 3, that is 18 by 500 ampere. In milliampere, it is I equals to 18 into 1000 by 500 milliampere. That is 18 into 2, 36 milliampere. So the answer is 36 milliampere. B is the correct answer. So question number 41 having the correct choice B. Now let us see the question number 42. In question number 42, we see that if alpha and beta are the current gain in the CB and CE configuration respectively of a transistor circuit, then beta by minus alpha by alpha beta. We know that beta equals to alpha by 1 minus alpha. Next 1 by beta equals to 1 minus alpha by alpha, that is 1 by alpha minus 1, 1 by alpha minus 1. So 1 by beta minus 1 by alpha equals to minus 1. So 1 by alpha minus 1 by beta equals to 1. Then alpha beta is here, beta minus alpha by alpha beta equals to 1. And we need that beta minus alpha by alpha beta equals to 1. So B is the correct option. So correct answer to the question number 42 is B. Now let us see the question number 43. Here is a gate circuit question. The Boolean expression for the given circuit is asked. Then we see that here is an AND gate, 2 inputs are A and B. Then the output is AB inverse, that is your A inverse plus B inverse from Morgan's theorem. And for the second case, here is a NOR gate. It gives A inverse plus B whole inverse, that is your A inverse plus B whole inverse, that is your A inverse inverse is A into B inverse. And ultimately, both outputs are actually connected to the input of a OR gate. And the OR gate actually gives you the addition, and ultimately the addition will be A inverse plus B inverse plus A B inverse. Now, keeping A inverse intact and taking B inverse common, 1 plus A. 1 plus A means 1. So the answer is A inverse plus B inverse, that is A into B inverse, A into B whole inverse. So is the correct option 43 question number having the correct answer A. Now let us switch over to the last page. It is also a Boolean algebra circuit. input and output voltages are given to for a NAND gate. Now, input A and another input B are in off state. They are 0, 0. 0, 0 when they are fed, Y equals to actually for NAND gate it is A into B inverse. A0 or B0 means 0 inverse means 1. The first stage is output is 1 and output 4 outputs are given. We have to choose the correct voltage option. Next, in the second case, A is 1, B is 0. So AB is 0, AB inverse is 1. So in the first case output is 1, in the second case output is also 1. In the third case, A is 0, B is 0. 0 into 0, 0, output is also 1. In the fourth case, A1, B1, A into B, 1 into 1, 1, output is 0. So in the first three cases it is 1 and in the fourth case it is 0. It is found in the option B. So 44 question number 44 having correct answer B. Now let us see the last question. That is the 45th question of the lot. What we see, a silicon specimen made into p-type semiconductor by doping on an average 1 Indian atom per 5 into 10 to the 7 silicon atoms. If the number density of atoms in silicon specimen is 5 into 10 to the power 28 per meter cube, then number of acceptor atom in silicon will be. All options are in atoms per centimeter cube, atom per centimeter cube. But here specimen is given atoms per meter cube. So the number of density atoms in silicon is 5 into 10 to the power 28 atoms per meter cube. Atoms per meter cube. 1 meter cube equals to 10 to the power 6 centimeter cube. So it is equals to 5 into 10 to the power 28 by 10 to the power 6 atoms per centimeter cube. That is 5 into 10 to the power 22 atoms per centimeter cube. Now, how is it doped? A silicon specimen made into a p-type semiconductor by doping on an average 1 Indian atom per 5 into 10 to the power 7 silicon atom. When for 5 into 10 to the power 7 silicon atom, we have doped 1 Indian atom. So for 1 silicon atom, it is doped with 1 by 10 to the power 1 by 5 into 10 to the power 7 atoms. So for 5 into 10 to the power 22 silicon atoms, it is doped with 5 into 10 to the power 22 by 5 into 10 to the power 7. That is 10 to the power 22 by 10 to the power 7, that is 10 to the power 15. So the answer is 1 into 10 to the power 15 atoms per centimeter cube. So B is the correct option. So the question number 45, that is our last question, having correct option B. And that is the whole theorem answer is given to you. Now I am giving you the MCQ type answer. Question number 1 having correct option A, 2 having option D, 3 option A, 4A, 5A, 6B, 7B, 8B, 9A. Question number 10 having correct option A, 11A, 12D, 13C, 14A, 15D, 16A, 17A, 18C. 19A, 20D, 21C, 22C, 23D, 24B, 25C, 26D, 27C, 28D, 29B, 30C, 31B, 32A, 33B, 34D, 35B, 36D, 37C, 38D, 39C, 40B, 41B, 42B, 43A, 44B and 45B. And now that is the end of our discussion actually. Our next mock test will be mock test number 4 and the topic of that exam will be S.H.M simple harmonic motion, whole wave, bulk properties of matter, full chapter, kinematics, thermodynamics revision, and that question paper will have 45 questions, and date of probable date of that exam, that is our mock test 4, is 3rd June 2020.